Okay, so you should be able to see my screen. Let me know if there's any issues. Okay, so question number 4 is similar to this one where you want to solve by graphing. So step 1 when you're graphing this is you want to always put it in the form y equals. So you can only put in your graphing calculator once you have y by itself on either the left side or the right side. So in this case, you always want y to be positive. So that means I'm going to move everything else to the right side of the equation other than y. So I'm going to do question number C. There you go. So I'm going y equals, I'm bringing x squared over, so it becomes negative x squared. I'm bringing positive 16x over to become negative 16x. And the minus 59 stays on the right side, so you don't change that one. Okay, so that is now solved for y. You need to do the same thing for the second equation. So that's a linear equation where you have x minus 2y equals 60. We're going to swap these two spots. These two numbers, we're going to swap their positions because we want always y to be a positive value. So it's going to be x subtract 60 because you're moving it across the equal sign. And then negative 2y becomes positive 2y on the right. And then lastly, I'll divide everything by 2 to get rid of to get the y isolated. Y equals then x divided by 2 minus 30. So these are the two equations that I'm going to put into my graphing calculator. Okay, so y1 is, it really doesn't matter which order you put them into. So I'm going to go and do that for you guys. So I have negative x squared minus 16x and then minus 59. And then your second equation into y2, x divided by 2 minus 30. Then you want to set your window. Usually I start with the standard window, and if I can't see an intersection, then I'll adjust it so that way I can see it a little bit better. But I do know that the y-intercept for the linear one is negative 30, so that's something to keep in mind. Oh, let's fix that. So my window, adjust it to the standard window to start. Okay, so as you can see, I don't see an intersection. So that means that the graph is way lower. So if you look, my linear equation is x over 2 minus 30, which means that the y-intercept is minus 30. So I'm going to adjust where my y values are way lower. So instead of stopping at negative 10, I'm going to go lower and go to maybe negative 50. There you go. Okay, so as you can see, I see one intersection, but there's probably another intersection because we have a parabola shape. So the blue probably continues and there possibly could be another one. So again, this is where the thought process comes in, where you have to say, what should I adjust? I have to adjust my x minimum to be lower. So maybe again, let's go to negative 50 for your x minimum. So this is good. So as long as you see all possible intersections, and in this case, it looks like there's 2 solutions. So you need to find the coordinates for those 2 solutions, so you have to do one at a time. So you're going to press second trace number 5, and you're going to go as close to the intersection as you can with your cursor, either moving left or right. And then for you guys, you're going to press enter 3 times. So I'm going to press enter, and it should say, if you did it properly, mine is not liking me right now. Okay, mine's not working, of course. First curve, second curve, guess. Okay, so there you go. So it should say intersect or intersection, and the coordinates for mine would be negative 14.5 and negative 37.25. So that is what you need to write in as your solution. Okay, graphically, your calculator will only show real solutions. So once you do them with your graphing calculator and you put them in, it won't show you extraneous solutions, which is nice. So these are 100% solutions as long as you graphed it correctly. So that is one solution, and now you have to find the second intersection by going again and pressing second trace, number 5, Move your cursor as close to the intersection as you can. Press enter 3 times. And my second one is -2 and -31. Okay, so that is what I would say is my intersection. Therefore, the intersection is this. Okay, so verify your solution. What you could do is you could plug in, if they ask you to verify, you would plug in these answers into either one or both of the equations to see if left side equals right side. So for example, this is how you can verify. Let's plug in -2 and -31. So x is -2, y is -31. So -2 minus 2 times -31. So I'm plugging that into this equation here. So this is the second equation. It's much easier, which is why I'm choosing this one. So we're checking, does the left side equal 60? If it does, then we know that this is correct. So I'm putting -2 minus 2 times -31 in my calculator, and I get that the left side and the right side are both equal to 60, and that is how I verify. Okay, so then you would also verify that those coordinates into the first equation just to really be sure. And then you would repeat that same step with this set of coordinates right here. Okay, so that is how you verify, is by plugging it in and seeing if the left side of the equation equals the right side of the equation. So that is question 4 for you guys. Any questions about that one? Give me a thumbs up. Let me know if you guys have any issues with that. So just to summarize, solve for y, plug it into your calculator, set your window so that you can see the intersections, and then find those intersections by going second trace number 5. You guys good? Go into chat, give me a thumbs up, say good. Perfect. Okay, I just needed one person to let me know that they're still alive. Okay, let's go on to question number 5. So this is where you have to do it algebraically. There are 2 ways to do this algebraically. So I'm actually going to model both methods for you, and then you can choose which method you prefer. Okay, so there is a benefit to having or knowing both of them. So that's why I do want to kind of demonstrate them. So it's something that you did in 10C. It's called the process of elimination and a process of substitution. So hopefully that kind of rings a bell, but if not, then just make sure you go over that lesson from, I think it's 8.2, 8.1 or 8.2. So where I go through both processes. Okay, so first of all, if you're doing elimination, this is a way of doing this algebraically. Elimination is where you line everything up, okay? So I line them up, 8x squared. Now, underneath it should be 6x squared. Then I have a minus x, but if you notice, the first equation doesn't have, because I'm doing this one, the first equation doesn't have a variable of x. So what I have to do is I put a value in even though it doesn't exist. So this is a process that is helpful for 30-1 when we do something called synthetic division. So synthetic division, we actually put in a 0 even though there's no value there, just to show that there is a place value. So it does still exist. It's just we don't see it, right? It's 0 times x is still 0. So we do want to show that that is still part of it. Then I would go plus 5y, everything else stays the same. So only if you see that there's something that doesn't line up with the other equation, that's where we put in a 0 with the variable that is missing. And now, what we want to do in this one is we always want to eliminate the variable y. So you have to get the coefficients being the same. As you can see, the variables, the coefficients are not the same. One's 5, one's -3. So we have to multiply the first equation by possibly 3. So we're going to multiply that whole row by 3 to get it to have a common factor of 5 and 3. Okay, so we're just multiplying it by the other number, and that's just a quick process. This row, we're going to multiply all by 5 so that the numbers in front of y will both have a 15, and then we can actually eliminate it, because you can't eliminate it if you have different coefficients. So our next step would be multiplying the 3 in, so that's going to be 24x squared plus still 0x plus 15y equals 300. So that's our first row. Our second equation will be multiplied by 5, so that's going to be 30x squared minus 5x minus 15y, which is equal to 25. Okay, so once you have the same numbers in front of y, you look at the sign in front of them. If they have the same sign, you are going to subtract the equations. If they have a different sign, which they have in this case, you're actually going to add the two equations together. So you're going to add each column together. So you're going to do a big addition sign. And so we're going to start with 24 plus 30 gives us 54x squared. And then we have 0x plus negative 5x is just going to be negative 5x. And then what should happen if you do this properly is, if you look, positive 15 plus minus 15 will actually eliminate and cross each other off. So that's the whole point of elimination. And then 300 plus 25, I don't know why I put that in my calculator. It should be just 325, okay? Now, if you guys look, this is a quadratic equation. So if you ever see a quadratic starting to form, you want to bring everything to one side and set it equal to 0. So 54x squared minus 5x, we're going to subtract 325, and that should equal 0. So this is the equation that I'm going to now, I'm going to do either quadratic formula with, or I can do factoring if possible. I can do like completing the square and solving. So whatever you want to do to solve this. Of course, I always find that it's easier to do the quadratic formula. So A is 54, B is negative 5, and C is negative 325. So I'm going to put that into my quadratic formula. B squared minus 4AC divided all by 2 times A. So that's going to give me positive 5, and then I'm going to put that whole thing in my calculator. So I like to always do the radicand by itself first, so that I don't have any issues. And I get this number underneath as my radicand. And 108 at the bottom. Okay, so this is what I'm solving for, and these are the two x values. So once you find your two x solutions, you're not done, unfortunately, because just like in the previous question, you always need an x coordinate and a y coordinate when you're talking about points of intersection. Okay, so I'm going to solve for the square root of 70,225, and I get 265. And there's two solutions. One is where you add 5 plus 265, get the answer, and divide it by 108. So you should have 2.5 as one possible x answer. And the other x solution could have been 5 minus 265 divided by 108. Okay. So once you have your two x values, you're going to have to go back to the original question and then solve for y. So I like to always use the easier one, which is this guy right here. The first one is slightly easier to look at, so it should be 8x squared. Then we have plus 5y equals 100. So we're going to plug in x equaling 2.5 and solve for the y coordinate. So 8 times 2.5 squared plus 5y equals 100. We're going to isolate for y. So 5y, this is going to be 100 minus this whole thing, guys, equals 50. So I'm just going to bring it to the other side right away, to the right side, to subtract 50. So then it's going to be 5y equals 50 divided by 5. So the y coordinate is 50 divided by 5, which is 10. So I need to write that one intersection point could be 2.5 comma 10. Okay, so that's one possible solution. Now, it's not really a solution until you've actually checked. So that is always a step that you need to do. And then you're going to repeat that with this number right here. Now, keep in mind that since we've rounded this x coordinate, the y coordinate will be slightly off, but that will be fine. So you're going to go 8 times negative 2.407 squared plus 5y equals 100. Put 8 times negative 2.407 squared in your calculator, and I'm getting like 46.349. Plus 5y equals 100. I'm going to bring that to the other side by subtracting from 100, the 46.349. And I get that 5y equals 53.651. Divide both sides by 5. So that's going to be approximately 10.73. Okay, so that's my second set of coordinates. So the coordinates would be then negative 2.407, comma, 10.73. Okay, so that is how you do that, that process with elimination. Now I'm going to redo that question, but I'm going to do it with substitution, because it is an important kind of skill to have and know how to do substitution. Okay. So I'll start with the original question. I'll just rewrite that for you guys. So now I'm doing substitution. My short-term memory, I have to keep scrolling up, minus x minus 3y. And my last number is 5. There you go. Okay, so in this one, substitution is where you take one of the equations, whichever one is easier or better looking, I think, and you try to solve for y. Okay, so I usually try to pick the one that's going to give me as little fractions as possible, but that's not always possible. In this case, it's not. I'm going to have a fraction, so I'm going to choose equation number 1. So I'm going to solve for y. So that's going to be 5y equals negative 8x squared plus 100. So I brought the 8x squared over, and it became negative 8x squared. And you're going to divide everything by 5. So y is equal to negative 8 over 5 x squared. And then it's 100 divided by 5, which is 20. So this is my y equals equation. What you're going to do now is whatever y is equal to, you're going to take that and substitute it into this y right here. So you are going to have to work with fractions in this one, which is why in this case, I actually prefer elimination, because you don't have to work with fractions. But it is good practice to get used to it. So you're going to take 6x squared minus x minus 3y, but instead of the y, you're replacing y with negative 8 over 5 x squared plus 20. So that's what is being replaced in the y spot. So this whole thing went into the y area, and then the 5 is still there. So this is my new equation where, as you can see, I only have one variable, which is x, and that will help me get a quadratic to be able to solve for that. So to solve this and further and go further, you're going to have to distribute the 3 into the brackets. So this is like saying negative 3 over 1 whenever you work with fractions. So negative 3 times negative 8, you always multiply the tops together. You're going to get positive 24x squared over 5 plus negative 3, actually it'll be in minus, negative 3 times 20 is negative 60. And that should equal 5. So this is the distribution kind of part that you have to distribute any coefficient in front of that bracket. So as you can see, you're going to now start to get like terms. So these guys can go together. So you're going to have to add 6 plus 24 over 5 in your calculator. So I'm going to do that to the side just to show you that you can do it in your calculator by going math, enter, enter, and changing fractions, decimals to fractions. But it is good to know how to kind of work with this stuff. So whenever we add fractions, we need to get common denominators. So you're going to multiply this by 5 to get you 30 plus 24 over common 5. So 30 plus 24 is 54 over 5, and that's what you're going to have in front of x squared. So that's joining those two like terms. And then we have a minus x, and then finally we have minus 60, and we're going to have to subtract 5 from that because we're moving everything to the left side of the equation. So your final kind of step here, well, not final, but to get the quadratic, you're just joining together the like terms. So at this point, you can now switch to either graphing this and finding the x-intercepts. You can again use that quadratic formula to find your x-intercepts, whatever process you want. So I'm actually going to shift just to kind of show you a different method. I'm going to go to the graphing calculator. I'm going to graph this and find the x-intercepts, which is what you learned in the quadratic unit on how to solve for these equations. So in my graphing calculator, remember this process always works. So you can always shift to this calculator for this kind of section. So 54 divided by 4x squared minus x, and then minus 65. So I'm going to graph this, and I have to find those x-intercepts. So as you can see, it's an upward-facing parabola. So I go second trace, number 2. I go to the left side of that x-intercept. Oh, come on. It's not letting me do that, of course. Let me change my window. So I'm going to go to the standard window. And then there you go. Second trace, number 2. There you go. Go to the left side, press enter, go to the right bound, which would be about here. Oops, left bound, still didn't do it. Come on, you. Left bound. Do it, do it, do it. Just going to shift. Okay. Right bound, as long as your y is negative, you know you're in the right bound for that left one. And then my 0 is negative 2.407. Negative 2.407. If you guys look, that's the same answer I had over here. So I know that I'm doing this properly because using the other method, I am getting the exact same answer. And then we do know that it should be then 2.5 for the next one because we already did this using the elimination process. So second trace, number 2, go to the left bound, which is below the x-axis, press enter. Right bound is where y is positive, press enter, and you should get 2.5, okay? And then just like in the previous case, once you have your two answers, you plug them back into the equation, which could be this one right here, if you guys see. If you plug it into that equation, you can then solve for y, okay? So it's up to you which one you want to choose, if you want to use elimination or substitution. Those are your two choices for that last question. And so when you verify, you could graphically verify, whatever. So your choice in how you choose to do that question, okay? So that is the new stuff. If anybody wants to stick around, I'm going to be going over question one with fractions, because somebody was asking me about that one. So if you do want to stick around, if not, I'll post this recording later on if you guys want to take a look for it. Hopefully that helps you for questions 4 and 5, and then let me know if you have any more questions about that. So I'm going to go on to question 1, which this is like the last one, okay? So if you are good, I hope you guys have a nice week, and let me know if you guys are having issues getting your assignments done so I can help you and get them into me so that you're not burdened with this stuff. Okay, so this is question 1, the one with a fraction. So you kind of want to work on the inside and work your way out. Okay, so I'll try to kind of like work on it in pieces and then see what happens. So 6 squared is the same as 36, right? So I'm doing that first. And then I have this BEDMAS means I have to do brackets here. So 10, we're going to go 2 minus 3, which is -1. We're going to have to square that. And then what you need to keep in mind is that these absolute lines are just like brackets. The only thing they do is they change negatives to positive. That's it. Otherwise, you treat them identically to brackets. So here, this is going to stay positive. That's not going to change. But these two guys are going to multiply together. The numerators always multiply together, and the denominators always multiply together. So this negative is going to multiply with the positive to get -10 over 6 times 3 is 18. And then you're going to add 3 to the power 4, which is 81. So that's what I've simplified so far. I've kind of looked at it in pieces and did those kind of multiplications together. Then I still have 36 plus. Now I'm going to work with -1 squared is 1. And -1 or +1 times 10 is 10. Okay, so all I did was I simplified this to be 10. So all I have now is 10 minus 10 over 18 plus 81 in absolutes. Our next step is to combine the 10 and the 81. These are like terms, so we can simplify that by going 10 plus 81 in our calculator, and you get 91 minus 10 over 18. Now we need common denominators. So in order to add or subtract fractions, it's all about getting common denominators here. So I'm going to multiply the bottom number, which is 1. Even if you don't see it, 91 has a 1 underneath it. I'm going to multiply this by 18 and the top by 18 so that it has a common denominator with 10 over 18. So I get 1638 over 18 minus 10 over 18. So 1638, we're going to subtract 10, and you put the tops together. So whenever you have common denominators, you only work with the numerators then. So I've subtracted 10 from that number and got 1628 over 18, which is our common denominator. And lastly, if you guys look, this is a positive number, so that's not being affected. A negative number is the only thing that's going to become positive, so you can leave it as it is, and it just becomes 36 plus 1628 over 18. Our last step in this question is, again, to get common denominators. So we're going to have to multiply the bottom by 18 and the top by 18 so that we can add the two fractions together. 36 times 18 is 648. And it's over a common denominator of 18. So we can write it as one common denominator. And finally, you just have to add those two numbers together. 648 plus 1628 gives you 2276 over 18. And then my last trick that I always do is I always go and put this fraction into my calculator and I press math, enter, enter. So if you press that number exactly how you see it and press enter twice, it will simplify the fraction for you and give you a final answer of 1138 over 9. So that's the simplified fraction that I would write as my answer. Okay. How's that, Yusuf? Is that helpful? Okay, perfect. Let's go on to question number 2. Okay, so question number 2, I'm trying to remember what the questions were. Let's see. Question number 2 wants you to determine the y and x intercept, sketch it, domain and range, and the piecewise function. So let's do this one. So step 1, I'm going to find I'm going to graph this. So I'm going to graph this and then sketch what it looks like. Okay, so I'm just going to write it down so I don't forget it. -5 over 6 x plus 2. Okay, so in my graphing calculator, the buttons that you press to do this is you press math, number, and then it should say ABS. So you're pressing number 1. So this is what should appear when you put in absolutes. And then you put -5 divided by 6 multiplied by x, and then plus 2. So when you graph it, you can use the standard window, and this is what I'm getting, okay? So what's important is they want the y-intercept. So to find the y-intercept, you're gonna press trace 0 enter. So I'll write down that step for you because my calculator doesn't do that. So you're gonna do trace x equals 0 and press enter. So if you look, my calculator gave me, mine I'm gonna have to do a few other steps, so it's not the same. My value is giving me a y-intercept of 2. Okay, so that's what you would do to find the y-intercept. And then I can use that to plot it. So I know that the y-intercept of 2 is right there approximately, so plot that. This is my y-axis, this is my x-axis. Next thing I want is I like to always find the x-intercept algebraically. It just helps me because I just use the equation without absolutes for that. So what I do is whenever you're trying to find the x-intercept, set y to 0. Move the 2 to the other side. It becomes -2 equals -5/6x. Then you're going to get rid of that 6 by multiplying both sides by 6. So that's going to be -12 equals -5x. And then you're going to divide both sides by -5 to isolate for x. So I know that my x-intercept will be 12 divided by 5. So that's approximately, well, it's actually equal to 2.4, a positive value. Now you can confirm this if you want. You can go to your graphing calculator and press trace and put in 2.4. And it should, if you press enter, it should give you that the y-coordinate is 0. So that is your way of confirming that you did this properly. So I just found that the x-intercept is 2.4. And then that also is what I want to plot. So 2.4, draw that. Once you have one side complete, it's always symmetrical on the other side. So then I can draw my picture. Make sure you include arrows on both sides to show that it does continue on forever. Okay, so now you want the domain. The domain is going to be XER because it continues forever left and right. The range for most of them is going to be y such that y is going to be greater than or equal to 0 YER. So it always goes from 0 and up. Of course, if the whole graph moves upwards, that would change it. But for now, it's going to be 0 and upwards. Okay, so that's your x, y-intercept sketching. I just want to see if I'm missing something. I think it's the, okay, so we did the y and x-intercept, we did the sketch, we did the domain and range, now the piecewise function. Okay, so piecewise function. So what I start by doing is I say y equals, and I have this big curly bracket to say that the equation could be part of the equation. This absolute is made by taking off the absolutes and leaving it as it is. This is called like the positive version of it, where if you multiply everything by a positive sign, it doesn't change anything. The next version is where you multiply everything by a negative, and that changes the -5/6 to +5/6x, and then -2. So that would be the negative version of it. If you look, and if you were to graph these individually, you would see that because of this negative sign, I know that this is a downward facing linear equation, and that would match this piece. So whenever we look at a graph, we kind of have to divide the graph wherever we see x-intercepts. So I know that the purple one is represented by what is to the left of this x-intercept of 2.4. So I would say, I know that the graph is going to exist where x is less than 2.4. Okay, so that would be how I write that I want this purple piece. And then let's say I want this orange piece. Well, this is an upwards increasing kind of linear equation. And if you look, this is a plus sign. So that has to be that piece there. If you drew it, it would go over top of that, that right piece. So to write the right piece, you have to say x is now bigger than 2.4. Okay, so this is what you do is it's either going to be one piece or the other piece. And then finally, you have to put an equal sign under one of these because you need to include 2.4 in one of the sets so that it is not, you're not just, you don't have a gap in your graph. So you do have to include the value of 2.4 in one of these two equations, but not in both. Okay, so that is the piecewise function, and this would be your answer. Any questions, Yusuf? Nope, you're good? Awesome. Okay, hopefully you have a good day. Thanks for joining me and enjoy your week, okay?